Hello everyone, today we're gonna solve the four-sum problems. This is very similar to the three-sum problem I used to solve before. If you guys haven't seen the three-sum yet, check it out at the end of the video. I will put a link right side. So for the four-sum problem, first of all, we are gonna have to understand the problem first. So in this problem, we need to return all the four numbers so that the sum of them will be equal to target number, and we can return the answer in any order. For example, with the target equal to 0, we're gonna have this four number -1 -2 will be -3 +1 +2 gonna be 0. So the sum of them gonna be 0. And then in the second case, we're gonna have target gonna be 8, and we're gonna have this number, this four number, and we cannot return any duplicate four numbers. We have to return all of them as unique. So first of all, to do that, we can use for loops to choose uh, all of the four number. The first approach have for loops, and with this approach, obviously, it's gonna take O and the power of 4 time complexity. And for the approach 2, we can first we sort the array, then we can use three loop, and we can use a binary search for the last for loop. So basically, we can speed up the last loop from ON to O log N. The N to the power of 3 line with log N. And then for from the optimal approach, we're gonna have to sort the array, and instead of using three loop and binary search, we're gonna use two loop. And for the last two number, we're gonna use two pointer to choose the last two number. So it's gonna be O and to the power 3 instead of multiplying with the log like this. So how can we do that? First of all, we're gonna have to sort the number from begin to the number to end, and then we're gonna do the same for I equal to 0, I less than n. Choose the first number and we choose the second number, right? And then to avoid choosing duplicate number, we're gonna do the same thing when we did for the threesome problem. So if we have the numbers of I equal to numbers of I, we're gonna skip number I. Then we want to make sure that we don't consider the negative indexes. So I'm gonna put if I greater than 0 right here. And we're gonna do the same for j. If we have j greater than, actually, +1 and +1, we have the terms equal to number j minus u. And then for the last two loop, we're gonna use just two pointer right here. So we're gonna have right gonna be equal to n minus 1. We're gonna have left gonna be equal to j plus 1. And we have left less than right, 3 left. And right here, for each of the left and right, we're gonna consider if we have the sum of I plus with nums of j plus with nums of left plus with num of right. If we have this number is greater than target, we're gonna have to move the right pointer to the to, we're gonna decrease the right pointer by one, right, like this. So let's consider both cases like this, and actually can consider if we have greater or equal, we're gonna decrease, and if we have right equal, this sum equal to target, sum equal to target, we can put both for these four number our result, right, and then we can have a vector result. This one is vector as well. Then we have this number. So we're gonna do the same. We're gonna consider uh if the right is different with n minus one, and or we have right less than n minus one, and we have the nums right different with num right plus one. We so that's when we will push it in our result array. Gonna put back nums I, nums j, f, and I like this. Perfect. Let me double check it again. I think that's look good to me. Then we return result right here, and time complexity gonna be O cube, and the space complexity gonna be O1. Topic for this one is Twitter and sorting. So this one have one problem that we we calculate the sum of four number, and each of the number have the limits of 10 to the power of 9, so which means that we can cause overflow error, but let's just submit to those first. Num size, okay, we have some error, right? Check if we have the right like this, F A, and oh, we're gonna have the same problem right here. We're gonna consider if the left equal to f minus one. Gonna just continue same f greater than j plus one. Gonna continue it. This one left less than right. Yep. Perfect. I think that's all for here. Perfect. I think we still have the problem right here, but just submit it to. Yep, exactly this test case. Then I'm gonna adjust this a little bit by multiplying with one long long, so that we can convert this sum on instead of integer. On same thing. This Awesome. So that's all for this question. Again, if you haven't seen my video on threesome problem yet, I highly recommend you to check it out before you try to solve this problem. Thank you. That's all for this problem.